All right, we'll get started now. You're welcome once again. Thank you for joining. Yeah, it's been an amazing couple of classes. Today is class 6 for the Machine Learning Basics program, bootcamp program. And today we'll be wrapping up with classification. So we'll be touching on last class we touched on logistic regression, predicting Titanic data survival of Titanic data sets of passengers on Titanic boat, and we were able to go through that using machine ML example and using the logistic regression model. All right, so today we'll be looking at some other algorithms, and would also be taking a look at feature selection, how to optimize the performance of our model using feature selection. Okay, and then we'll just be wrapping up with classification algorithm. So for this bootcamp, we're thinking they will touch on unsupervised learning, but then as it is now, we won't be able to, because by Friday would be introducing you to I'll be introducing to the capstone project today, because you have to get to start working on it. All right, so the capstone project has been uploaded on the LMS as well. So I'll be showing you capstone projects walkthrough, but I'll be showing you an example from next class, so that you would know how to approach your projects. Okay, but then the instructions have been given on the LMS starting from today's class. Here, this is where it was. Today is 17th. Okay, so it's here. All right, so we have the project instructions, the task, what you're supposed to do, and then the deliverables, how you're going to submit your project. Okay, all right, so the project is live now and should be submitted before the end of Tuesday next week, and that's why we are making it like even a week interval before the project submission deadline. And I'll be showing you the process in the next class, how to go about your projects for the machine learning task. So for people that enrolled in all the programs for the data science bootcamp, you're just expected to submit one project. You can try your hands on others, but then you're just submitting and presenting one of your projects. So you should just focus on the one that you'll be presenting and submitting for the demo. Okay, so I just thought to also talk about that. All right, so we'll get started into what we have for today. How are you all doing? Hope you had a nice day, or hope you're having a nice day. All right. Yeah, so just to wrap up what we did last class, logistic regression using the Titanic data sets. We looked at the Titanic data sets, and then we were able to evaluate, do some data exploration, data cleaning, right? You found out that there were some there's some missing values in the data sets, which was also tidied up. And then we had sorry, okay, let me continue. Then we looked through we went through the data set, we cleaned the missing values, and we imputed the median age for the age column, and then using a function that was defined by us, and then we did some feature engineering. This is the function, and then we went ahead to convert the categorical variables, most especially on the embarked column. We performed some feature engineering on the embarked column by splitting it into into separate columns using the one-hot encoding. All right, right. And then afterwards, we were able to get to the data sets that will be using as input for our machine learning algorithm. So we didn't use the name, we didn't use the gender, the sex, because we've already created new columns for it using one-hot encoding. We didn't use the passenger ID as well, and then we didn't use the cabin because it had missing values. All right. So afterwards, we went ahead to build our model, and then we built our model, and then we did and then we went ahead to do the model evaluation. Okay, so I just thought to do a little recap for what we did last class. So we're going to go right into what we have for today's class. So after building your models, right, there are ways by which you could improve the performance of your model. And one of the ways is to use other algorithms, which we saw last class. Sorry, I didn't know I was on mute. Okay, so would one of the ways is to use different other algorithms, or you also do some feature engineering, feature selection. So I'm going to be showing you example of how to go about feature selection on classification models. You know, we did that of regression, so I'm going to be showing you what you can use for classification. So let me just share the notebook quickly. Sorry for the break. Yeah, so for feature selection using classification. Now I'm going to give an example of a use case. For example, if we want to predict mobile prices, and this is a simple use case where we have somebody named Bob. He started his own mobile company and he wants to compete with big companies like Apple or Samsung. And he does not know how to estimate price of the mobile company his phone has created, because part of what you do when you maybe you're doing business is to do like a market survey to find out what your competitors' pricing model is, and then to know how to set your price point, what makes you unique, and all of that. So Bob has to he has to make a move regarding the price, but he doesn't know how to estimate the prices of mobile phones that his company had created. So what he had to do is that he collected some sales data of mobile phones for different other companies, for other various companies, and then he wants to find out if there's some relationship between the features of the mobile phone, like the RAM, the internal memory, the HDD, and so many other features of the mobile phone, and its selling price. Can we, like we have different manufacturers, the RAM sizes, the memory, the features of the phone, and the selling price. But then he's not so good at machine learning. I need your help to solve this problem. So in this is a typical case of having to deal with machine learning. This is a typical machine learning problem. Okay. And then how do you actually solve this problem using machine learning? Okay, so there are different ways to do that. Like, you have to, first of all, gather the data sets. After gathering the data set of all the companies that you want to, that you're trying to look at their price models, then you gather all of their, maybe the mobile categories that you're actually focusing on. After gathering all of those things, you have a lot of features that you have to use for your modeling, but then you need to focus on the most important features when you're doing your building your machine learning model. And so part of the benefits of feature selection is that it reduces overfitting. Overfitting is like having you not to focus on redundant data, because when you have a lot of redundant data in your model, you find out that there will be lots of noise in the model. The model is learning other patterns that it's not supposed to learn. And then when it has to see a real life data set, it fails, because you have the model learned a lot of unnecessary patterns in your data. So it reduces, when you're focusing on the most important features, you're able to reduce overfitting, and then you improve your accuracy score. And also you can reduce the training time of your data, of your of when you're training your model, because the larger the data sets, the larger the training time, the time it takes to train that model. So the time it takes to train gigabytes of model is different from the time it takes to train kilobytes of data. And in machine learning, your data quality is of very great essence. You need to be sure that you have good data for your model. Okay, because if you're having gigabytes of data, and out of those gigabytes of data, the quality of that data is not great. It's as good as you doing your model is what you're building. You're wasting money, you're wasting resources, you're wasting time, and also eventually the model might fail in implementation, or in doing real life scenario. All right, so feature selection is actually very great to help you focus on the best features for your model. Okay, so we have different type of feature selection. We have the univariate feature selection, and we have feature importance. And then I'm going to be using examples of how to use this feature selection algorithms. So like we had in regression, we talked about in regression, we had the F regression and we had the model importance, right? But here we have the univariate feature selection, and that what it does, it uses statistical model testing to select those features that has the strongest relationship with the output. So in this case, this is it uses a chi-squared statistical test for non-negative features to select like the 10 best from the mobile price range data sets. Okay, so here you see that when you import the data, we have the trained data set. We have the battery power, the color, the clock speed, whether it's a dual SIM or not. FC, I can't really tell, except I checked the data dictionary, whether it's a 4G, the memories, the depth, the mobile weights, the number of cores, and so many. It has about let me check the .info. So let me load this so that we can all see what we are talking about. Okay, there's a .info. So the price range, we have a 500 data set, and we have 21 columns. So that's a lot, right? We want to focus on the most important columns that would help the Mr. Bob to focus on the features that he needs to improve on, to get a very good price for his mobile company. So it doesn't want to focus on all of those features. Every other feature is good to be there in his phone, right? But then there are some features that it needs to focus on just to, get a very good, that customers will be willing to pay an high amount of money for. Okay, so we have 21 features in this data set. And if you look at the one that we actually looking at is the price range column. So if we do the price range column, you can see that we have 1, 2, 3, 4 categories, right? Where I'll have to check the data dictionary for this data set to know what the price range is. Maybe from 0 could be maybe the range of prices is between so amount of dollars to another dollars. I can't really tell, but then this is just the price category. Maybe 1 is saying this is a low, 2 is saying medium, 3 is saying high, or 0 is saying very low. That could be the price range category. So who can tell me what type of classification is this? Is it a binary classification or a multi-classification? You can drop the comment in the chat. This type of problem now that we're trying to solve, we want to predict price range with about 4 categories. What kind of classification problem are we trying to solve? Is it a binary classification problem or a multi-classification problem? Can you drop the answer in the chat? I'll be expecting to read from you quickly. I've not seen any answer yet. Did you get the question? We are trying to predict, right, the price range of a particular maybe phone model or mobile phone, the price range. What kind of problem are we solving? Is it a binary classification or a multi-classification problem? You can just attempt it based on what we've been discussing through the classes. Okay, I think because of our time, I'll just proceed. But I believe you can hear me. So this is a multi-classification problem. I mentioned earlier that a binary classification problem, what you're trying to do is you're predicting just two classes, whether it's a 0, 1, or true or false, yes or no, whether it's a spam or not a spam message, whether it's whether somebody is having malaria or not, whether someone has COVID-19 or not, you know, like two classes of output. That's what you're trying to predict under the binary classification. But in a case whereby your target variable, what you're trying to predict, is more than 2, you have it's when we have like 3 classes, 4, 5, and upward, it's a multi-classification problem. Okay, I just thought to ask that question just to know, you know, gauge our understanding, but let us just proceed. All right, so to reiterate what I'm saying here, we want to build a machine learning model to predict the price range of mobile phones. We want to help Bob to solve the problem with having to, you know, get the fixed price or get a particular what does it need to focus on for each price range he wants to set for his new mobile phone company. What are the features he should focus on? So in doing that, you need to apply feature selection such that you're able to, out of those 21 features, you're able to pick the 10 or the number, depending on the number you want, best features for the model that you want to build. Okay, so we're still talking about feature selection, and then we're looking at using the univariate feature selection, that is using the chi-squared statistical tests function. All right, from feature selection in sklearn package, feature selection function, we have the chi-squared, and here when you import, after you import the chi-squared, just like what we did during the regression, right, we have to split our data into our x and y. And here, your x column is your features, or that all the features that you're going to use as inputs in your model, apart from your target variable. So we picked all of the features. That is, we defined it as x. Then the y is the target column, which is the price range. Then to apply the skbest class, you know, there is this skbest function as well, where you can define the score function. So the skbest can accept different score function. We saw that it could accept F regression under correlation matrix, correlation feature selection, right? Then we have the model importance as well. And then here you can also set chi-squared as the score function. And then you can define your K as whether as the top features. Do you want the top 10? Do you want the top 5? If you want top 5, you write 5. If you want all, you just write all of the K, right? All of the features. But here we want the top 10 features. Okay, so this is the process of you instantiating the model that you want to use. And now you have to fit it. You have to fit this model with your x and y variables. Here now, just know that you are not building the data. I mean, you're not building the model yet. This is the place of you selecting the features that you're going to use, where you're going to get your new x and your new y values. Okay, so you have the fitting process where you have to fit your features and your label, after which you can now use this. When you fit it, now the best features has been generated and it's stored inside this fit variable. Now you can print out the fit score, can store it in the data frame, and also you can print out all the x columns. So when you print them out and put them in a data frame, here you're concatenating the 2 columns together, right? And when you do that, you can see all the specs, all the specifications of the phone, and the ones with the topmost scores, that is the ones that have the best highest feature ranking between all of those features that we have supplied this feature selection algorithm. So we can see here that the RAM is giving us the highest score, followed by the pack's height, followed by the battery power, followed by the width of the phone, the height of the phone, the width of the phone, the mobile weight, the weight of the phone, the memory, and which is actually very reasonable, because you find out that most people that want to buy phones, right, depending on the model anyway, apart from the model, then the company, if it's an iPhone or Android, right? So people are always particular about the RAM size. How fast is the phone? How sleek is it? Is the power very, sophisticated? Can it last for several days? You understand? So this is actually very, very reasonable. The talk time and all other features going down. So this is using the chi-squared feature selection model. So this is how to use it. So once you've gotten the feature, you can now decide to select those features as your inputs to build your machine learning model. Once you want to optimize your model, probably you first of all build a baseline model using that data set. Now you can go further to just select use to better optimize the model. You can decide that you don't want to use all the 21 features. Can I use the top 10 or the top 6, 5 based on your process? You can do based on your preference. Rather, you can decide to choose the one that is better suiting for what you want to do. And then you also, it's an iterative process, because as you use the 21 features, you take note of your accuracy score or whatever classification mode performance algorithm you want to use, right? You can, it could be the F1 score. You've taken note of it, then you can decide to use the top 10 feature. You take note of your F1 score, and the one that gives you the best score can be the one that you would focus on for your model. All right, so do we have any question on that before I move to the next one? We have any question on that? Okay, let us move to the next one. The next one is the feature importance. So there's another feature selection algorithm that you can use on your data sets to select your best features. So it's another the other one is called the feature importance. So what the feature importance do is that it gives you a score for each feature of your data. The higher the score, the more important or relevant your feature is towards the output variable. So all this the feature selection algorithms, they're like maybe experiments that people they've performed, and then they wrote it in form of functions that can be reused by anybody that is building models. So we have several other of them apart from the chi-squared and the feature importance algorithms. So we have also many other feature selection algorithms, right? So, but then I just want us to stick to this so that I don't bring in more complexity, but you can also read further to check other ones. Okay, so for feature importance, you see that most of them, they are the same process. It's the way you use all of this model, they're all almost similar. Okay, so like what we did earlier on, you start with defining your X and the Y, that is your features and your targets. And we can also, after defining, now feature importance is like an inbuilt class that comes with the tree-based classifiers. The tree-based classifiers, like we have some classifiers from the example, sklearn.example. We have a name called the extra tree classifier. So it's used to extract the best features from our data set. So you can import that from sklearn.assemble, import extract tree classifier. You know, the other one we used here was the choice squared and the select k-best. If you look at it, we have the select k-best and chi-square. They were used together. Select k-best was the function, then the chi-square was like one of the arguments that was used under this call function, okay, from sklearn.feature selection. But here we are using another feature selection algorithm from sklearn.assemble. All right, so this is just to plot the graph. So the first step is to define, to instantiate. You know, you can see that it still follows the same process. You instantiate by giving the model a variable name. So this variable name can be anything. Someone can call theirs a model, someone can call theirs ETSFs, anything. But then the most important part is that you have your extract tree classifier in a function. If you look at the other one here, you can see that the place of instantiating is here, where you have the select k best, right? And then here you see that you're defining, so inside that bracket there are some default parameters, right? But then you can define your own. So in this case here, we want to use the chi-squared. I want to set our k to 10, and that's why we are putting these two arguments inside this bracket. So if you just want to use the default that comes with select k best, when I do my shift and tab, you see that it's going to give you some of the defaults. So you can see that call function, callable, function taking two arrays, X and Y, return a pair of array. We have the score and the P values, or the single array with the score. So by default, it uses fclassif as its default function, which works with the classification tag. So here, if for regression, you can decide to set f regression as your classify as the feature selection classifier that you want to use. So here now, see, we are setting chi squared as our default parameter, and k can be all in some previous feature selection examples we use on regression. We set our k to all, but here we are setting it to 10, or by default is 10. We can set to 15 or any number you want to select. So you can also look at how it's used. You can see it here. Here they are using chi-squared as the as the feature selection model. So you can see that under the chi-squared. So I just thought to mention that so that you can see the relationship. So here we are focusing on the extract tree classifier. So after instantiating your classifier, you fit it with your X and Y values. After fitting it with your X and Y values, now you can print, you can print the feature importance. Remember, it gives you a rank. That is, it outputs a particular rank for each of your features in your data set. So here you can see that when you print the model feature importance, you can see all of the feature importance. But here at a glance, you might not be able to see them at a glance, how you know, how they are ranked. So that's why we're plotting a graph using the matplotlib. And to plot the graph, you can convert it into a like pandas series, set the index as the columns, and then you can plot it using a bar chart, using your plot the n largest 10 n large. If you increase this number, you see that it would give us more more plots than 10. So if you see now, here too is also stating that RAM is the largest, followed by the battery power, followed by the packs width, height. So if you go up as well, you see here that you say RAM is the largest. Now this one says height is the next, then battery power. So here it's saying battery power is the next, height is on that number 4. So you can see that different feature selection algorithm, they are giving you an idea of different ranks. But the most important thing is that it's still within range. It's still within range of the top 10. So if I want to like choose my top performing features, I'll still select the height, because height is not, if assuming height is not even appearing here at all, then I'll know that, oh, okay, maybe there's a problem somewhere. But you can see that we have the RAM, the height, the battery power, packs width, which is still within the range. You can see RAM, power, packs width. Let's see mobile weight, talk time. We have mobile weight. Mobile width, talk time is number 8. Okay, so we can see here as well that we have PC, int memory, clock speed, and encore. So here, PC is not here. Int memory is here. Talk speed is not here. So you can see the ones that are not here, and encore is not here as well. Instead, you have SCH. So I can pick the ones that are actually within, that are showing me, that within the top 10, compare it together and use those features as my next input for my machine learning algorithm and see what the results will look like. So that's another way to optimize your model using feature importance. I don't know if you have any questions. Do you have any questions around this before we move to the next thing we have? Any questions? Any questions, please? Do you have any questions? Okay, so since I'm not seeing any questions, so I'll just, I think, continue. All right, so we going to look at another walkthrough of how to build classification algorithms, classification models. But this time around, we're going to be using a random forest and decision tree. And these are also very, very strong models for classification. All right, they are good. They are very good where you have lots of classifiers in your data set. So you'll be showing. I'll be showing you a walkthrough of how to use it, and then how to build the model. So if you notice, you find out that most times the process is usually the same. So but for building the model, but the where you have slightly different approach is when you have to do a lot the feature engineering and the data cleaning. So the way somebody's going to do their feature engineering might be different from the way you're going to do yours, right? And that would impact on the results of your model. So, and then the parameters that they're going to use for their feature their model might set some hyperparameters. But even if you do your cleaning and everything very well, you find out that even with the default parameter, you should get a very good result. Okay. All right. So let us start with the lending club data. So there's this data from the lending club. If you go to lendingclub.com, and then they connect people who need to borrow money with people who have money. That is the borrowers with the investors. So as an investor, you don't want to invest in people whose profile does not have a great credit score. That is, they don't have their credit rating is very, very poor. You want to borrow people that would have a great return rate, that is, they'll be able to return your money when due, right? That is, they have a high probability of paying you back your money. So you find out that in like some of these companies, like maybe some of these financial institutions, some loan companies, they use a lot of machine learning algorithms in their processes, because gone are those days where you just lend people money based on just looking at, oh, because the person has a high inflow of cash, the person's salary is great, then the person has the ability of paying back. There could be some patterns on the person's financial record that it would only take machine learning or some algorithms to learn those patterns and would be able to tell you whether the person has a good credit score or not. So it's not just by, some people have great inflow and outflow of money, and then but then their history of maybe they've been borrowing money over time from other people and they've not been paying back. They don't have a good credit history, right? So if no matter how, so having a lot of inflow and outflow does not really matter whether the person will be able to pay back. But then, so for somebody that doesn't really have a great inflow and outflow, but then the person has a good credit history, probably the person has been borrowing money and has been paying back up to time, you find out that that person would have a good credit rating compared to the person that does not pay back, even though the person has a good inflow and outflow of money. So I believe you understand the use case here. So Lending Club, let's even check up the website. So this is the website, Lending Club. You find out that here you can take loans, personal loans. What do you use your money for? I want to use it on vacation. Okay, I need 10,000 US dollars. Let me check my rate. Oh, okay, it's forbidden. Is it because I'm not in the US? Okay, let's just focus on the training. I just wanted to check something. Anyway, all right, so we want to create a model that would help us to predict whether people will be able to pay back a loan or not. Okay. If the customer meets the credit criteria of Lending Club or not. So that's the use case. So Lending Club has a very interesting year if you read this. So let's check out some data and keep the context in mind. The data is from the before they went public. So this is a very old data set. Okay, so we have the columns and what they represent. We have the credit policy. If it's one, then the customer meets the credit underwriting criteria. If it's no, the person is not meeting the criteria. The purpose of the loan, just like you saw, I was trying to write vacation. So the purpose of the loan, the interest of the loan, all right, the monthly installments, the natural log, debt to income, and FICO credit score. So there's a credit score based on some financial institutions, right? They have their credit score for each of the borrowers, the number of days the borrower has at a credit line, the borrower's revolving balance, as unpaid amount unpaid at the end of the credit and credit card billing cycle. Maybe there's some existing loans that the person had borrowed and then has not finished paying. The borrower's revolving line utilization rate, the amount of credit line used relative to the total credit available. The borrower's number of inquiries by the creditor in the last 6 months. The number of times the borrower had been 30 days past. So all of this, right? Like this one is a very, very great indicator. If the person has been 30 days past due on payments in the past 2 years, so that's a big red alert. All right. And the borrower's number of the regulatory public records like tax lien, judgment, bankruptcy filing. So anybody doing this kind of projects, right? You have to have a background of what the data is so that you'll be able to know, take necessary initiatives on what to do with the features. Now, as usual, the first thing is to import your libraries that you'll be using. Then you get the data. It's a loandata.csv, reading your CSV file. Then you can check the information. So let me just, because I might have to write some things. Let me load this as we proceed. Let's check the information. So this is a very nice data set. We don't have null values. We have a perfect, complete, non-null, right? And then we have about 14 columns. Then we can check the info or the head of the data just to see what the data set looks like. We have the credit policy. This is the one telling us whether the person is going to be able to is liable for a loan or not, the purpose, interest rate, installment, log. So we read all of the description earlier, the FICO score, the days with credit line, and all of that. Okay, so having all of that, you can do some exploratory data analysis. So we're going to use Seaborn and Pandas, to do some exploratory data. So we want to create an histogram of two FICO distribution on top of each other, one for each of the credit policy volume, income, rather outcome. So we have the first credit policy as 1 and the second one as 0. And then we want to use an histogram. We are plotting two histogram on top of each other. So this is what you're doing here. So here, this plot.figure, you're setting a fixed size. That is, you're setting the width and the height of your visual. So that is what this is doing. Then here you're selecting so if you do this, let me just do this so that you see what the table looks like. So you can see that it's selecting all of the loans, the people that have their FICO, their credit score equals 1. That is all of the FICO numbers of the people that have their credit policy as 1. And the other one is those ones that have their credit policy as 0. So we want to see the histogram, the distribution between those two people. So here you can see that the ones with 1, they have you can see here, you can see that we have higher number of distribution than those ones with their credit policy as 0. All right, so moving forward, let us look at another figure. We want to compare those ones that have fully paid their loans and those ones that have not fully paid their loans. Okay, so you can see here that the ones that have fully paid their loans have theirs as low. Those ones that have their loan equals to 1. That is, they fully paid. They have their FICO as blue, and then the other ones as 0, as red. Okay, so if you also check the count plots using Seaborn, you see that you can decide to do a count plot on the purpose of the loan and the people that have fully paid or not fully paid their loan. So you see here with the visualization, you can see people that want to use their loan for debt consolidation, which is always very used for some people, have to borrow money because they want to use it to clear up some other debts. So you can see that those people that have fully paid, right, have theirs as blue. Those people that have not fully paid have theirs as red. And maybe it tells us why they want to actually use the loan for debt consolidation. You have some as credit cards. Maybe they want to use it for credit. You have some as others. You have some as home improvements. They want to use it to renovate their houses. We have some as small business. They want to use it to start a business. Some as major purchases. Some as for educational. So here you can see out of everything, we have more people under debt consolidation in the data sets. And they have more of them, having to they want to request for loan for that purpose. Okay. Let me continue. Uma, I don't know what you mean by no. To you, can you just I can't remember the question I asked at the time. Okay, so we can also look at the trend. So the reason why you do a lot of visuals when you're doing your modeling is because it gives you some insights regarding your data sets. I mean, the features that you want to use to build your model. So when you do data visualization, it gives you an idea of what your features, the relevant features could be. Okay, so we can see a joint plot as well, and it tells us the trend between the FICO score and the interest rates. So here, here you can see that this is a negative correlations. It's almost looking negative because it's away from the origin, and then it's like it's more like a right angle. If it's towards the origin, it's going to be like a positive correlation. And here you can see the person correlation saying minus 0.71. Okay, so this is showing us that the FICO score, as a FICO, the interest rate is reducing, the FICO score is increasing. So it's like an inverse relationship between the two columns. Okay, so also you can create more plots. This is an import to see the trend between the not fully paid and the credit policy. All right, so here you see here that our credit policies are set to 0 is for people that will be given the loan, and the ones that are set to 1, the ones set to 0 are people that are not going to be given the loan, and the ones set to 1 are people that will be given the loan. And then the ones that is that are fully paid, those people that are fully paid existing debts, it's that fully paid is 1, then the ones that have not fully paid is 0. So here you can see the two relationships between these two graphs. Here you can see that the credit policy red is around this place. Those people with the credit policy red, that is those people that are not going to be giving the loan, they have a low, they have an high interest rates on their record. And see the people with that will be given the loan, all right, they have a very high FICO score. These ones have low FICO score. So they have high FICO score and low interest rate. So that gives you like an idea of what your data set looks like. Now, enough of all the visuals. Let us get into our models. So let's check the info again. And we have, if you look at our purpose column, you see that we have these categorical variables that need to be transformed. All other ones are numbers, but this one is in text, so we need to convert it to number. So that has to be tidied up before we build our model. Okay, so here we need to transform it, the purpose column, into kind of we need to encode it, right? We need to encode the particular column. So if you look at the nature of this column, you can see this debt consolidation, credit card, and debt consolidation, credit card. So it's it does not have a specific pattern. So we're going to use the PD.get dummies. We want to encode it using PD.get dummies for to be before we build our model. And if you look at this part, right, you first of all select the column that you want to use, okay, and then you can apply PD.get dummies, the name of your the column, that is, we have the loans the loans data set. That's the name of our data set, called the loan, right? Okay, here you can see that our data set is called loan, and then with the next input we have the column name, that is the purpose column, and then we want it to drop the original column. So let me just load this up and you see what the final data would look like. So you can see here that our purpose column has been dropped, but then we have a new purpose column from here. We have, you can see purpose credit card, purpose debt consolidation, purpose educational, purpose. So all of these have been translated into new columns. We used our one-hot encoding to encode that particular column so that we can convert them into numbers. Okay, so now we have our data set. So you see that our columns are they are now more than necessary. We had 12 columns before, now we have about 19 columns that we have to work with. Okay, so here you have your train test splits. Normally you have to split your data set into your training set and your testing set. But before then, you select your X and Y, right? And then you have your train test split X, Y. Then this is like selecting 70% of your data as your train set and 30% as your test set. Define your random state as any number. And then you can decide to train your decision tree model. So decision tree is inside sklen.tree. It's not sklen.assemble, it's not sklen.linear model, it's sklen.tree. So by default, you can always know what this, even if you don't know where this decision tree package is from, you can just search for it on Google and then you see where it's from. You can see the documentation and it should show you how to use it, right? So you have that as your decision, you're importing your classifier that you want to use. And then the next thing is what? To instantiate it, to create an instance. And then to what? The next one is to fit it with your model. And after fitting, you can see this is the process of training. Now, the next thing is to make prediction. So here, when you make your prediction, you see that we have a precision, a recall, and F1 score. And here you can see this for the 0, we have the precision as class 0, you have precision as 85. And for the 1, you have a precision as 19. For the recall for class 0, you have precision as 82, and for 1, you have the precision as 24. So you see that the average of the precision is 75, 73, 74. And you can see that here we didn't even check for data imbalance to be sure that our data is not biased towards the towards the one that's the other class. So if we check, I think there was a place where we checked our data set for, let me just put it around here. After .info, let's just check .credit policy. Loans.credit policy. .value counts. Okay, I think I didn't get the name very well. Credit.policy. Okay. So because of these dots now, I have to use the square brackets. Right. Okay, so we have class 1 has 7,710, and class 0 has 1,868. So this is an highly imbalanced data set. It's so imbalanced. So we have more of the classes, the people that were given loans and people that were not given loans in our data set. So our data sets might be biased towards the people that were given loans. So, but let's look at the confusion metrics and see what the result is. So here you can see that our true positives here is 1989 and our true negatives here is 105. We have a lot of false positives and false negatives. So let us calculate the accuracy as well. We can calculate the accuracy score and calculate other metrics just like we did in previous classes. Okay, but before we go into that, I want to show you how to use random forest as well. So random forest too is another good model that is from sklen.assemble. decision trees from sklearn.tree, random forest from sklearn.example. I don't want to go into the explanations of all the how it works. Would should take care of that during the intermediate boot camp, or we can also read on it, so that I don't bore you with a lot of mathematical concept. But then it's a great algorithm for classification. So here you can define your number of estimators. You can set it up as any number that you want, depending on these are like hyperparameters when you're building your model, right? So you can set it up as a lower number or an higher number if you want. So if you read the documentation, it's going to tell you further about the number of estimators and what it does. Let me do a shift enter. Let's see if this would bring it up. Yeah. This is telling you the number of trees in the forest. So you can decide to increase your number of trees, or you reduce your number of your trees. But by default, the number of trees is 100. So here we are setting the estimator to 600. And then after instantiating your what, after importing, you instantiate. After instantiate, you train, that is using your dot fits. You train on the X train and the Y train. And after training, you evaluate, you make predictions on your test sets, and then you evaluate your model. So you can see that your random forest is giving you a better recall score. And if comparing it with your decision tree gave you 0.5 for precision, 0.75 for precision, 0.73 for recall, and 0.74 as the average of precision and recall. That's F1 score. But then for your decision trees, your random forest is giving you 0.78. So this is like doing better than your decision tree. And then if you print your confusion matrix as well, you can see that the precision has increased. The true positives has increased, the true negative reduced. Then you have more of false negatives and you have less of false positives in your confusion matrix. So here, the goal, depending on what here now we find out that the price, the lending club is tilted towards we must try to reduce the number of false negatives, false positive, because the model should not say the person has a good credit score. Well, the person does not have a good credit score. That's false positive. False positive prediction is saying, oh, he has a good credit score. That is, you should give him a loan. And meanwhile, the person is not a very good customer. That's going to cause a lot of loss to that business, right? So your false positive is also of a very good important. But for false negatives, it says that it's predicting that the person should not be giving loan, and meanwhile the person qualifies for a loan. So that is still on the lighter side, because it's not like it's any disadvantage to the business. Yeah, for the customer, it will be a disadvantage to the customer, because the customer will be wondering that, but then I should get the loan now. What have I not done right? But then to the business, false positives is what they should actually reduce. They should try to reduce false positives, because they don't want a situation whereby there's a false alarm, the person is not eligible for a loan. The machine learning model should not be telling you that you should give the person a loan, or maybe you go and give the wrong person a loan, and then the business is in debt. All right. So in that case, you'd also focus more on reducing your false positives. See here, this now you have a lot of false positives here. So here you just have to get to reduce. This has been reduced to 8, which is very great. But then you also need to be careful that your model is not overfitting. That is, it's not biased towards the one with biased towards the majority class. The majority class in this case is for people that were giving loans. at the end of the day. So now we can also write which model performed best. Here we can see that it's a random forest. Yes, and then we notice the recall for each of the classes, and we need to do some feature engineering to also better increase this score. So part of what we could do here now, we can do feature selection. Here, we used all of the features in our data set. We can now apply one of those feature selection algorithms that we used earlier. We talked about, can apply feature importance to see what the results will look like. Then we can apply chi-squared as well to see what the results will look like. Would it be a better result, or will it be otherwise? So that's what you can do to this model to find out if you can get a better performance for your algorithms. Okay, I would like to pause here. Do we have any questions? Do we have any questions? Have I lost anybody? Okay, I believe we are still following. Anyway, this is recorded, so you can always go back to, you can go back to always rewatch and, try. So let's just apply one of the feature selection algorithms so that you can see how it is used. So because of our time, I won't want to type so much. Let me just do some copy and pasting here so that I don't have to get to type a lot. We're working on this lending club data, right? Okay. Let me just minimize this and okay, I'm trying to, okay, yeah. So I'm going to do feature importance for now the random forest model is doing well. So I'm going to do feature importance before this, the building of the model. Now let's just do that. Okay, so we have this. So the first thing is to import, right? Now I want to let's try we can try the two. Let's try the two. Let's import our data. Import our feature selection algorithms. Then let's apply our feature selection algorithm. So I'm going to use this. I don't need the X and Y. Okay, I think I need the X and Y. Let me just use this one. Do this. So that's all right. Okay, so we have the X and Y the X and Y data sets, right? And then we want to build a feature selection model for it. Okay, so now the first step is to, after importing our feature selection algorithm, we define our X and Y, right? After defining our X and Y, we apply our chi-squared to all of the X. We define our select k best instantiate it rather, and also define the chi-squared as the score function. We fit it, and then we get out the scores of the feature selected. The columns, and also we get out the column names. All right, you see that the process is actually the same. So if I just do this, so here I can change it from specs to let me change it to lending features or something. I'll just change it to one of the something else apart from specification. Let me change it to lending named as features. Okay, and the score. So when you load it, you can see here that the score, the largest score is the revolving balance. The next one is days with credit line. The next one is installment, revolution utility, and all of that, FICO, and the rest. So I'm going to do the same for, this is the chi-squared, right? Let me just add this. So we're going to use the features. We're going to use it to build the models, and let's see, maybe our accuracy score will be better or it would not. Okay, so let me just quickly do this. So this is the chi-squared. Put together feature select, univariate feature selection. Okay, so I'm going to do another one for a feature importance. Okay, I believe we are following. Then let me get the code as well so that I don't have to copy and do so many copying. Okay. So like we did for the other one, right? I don't need this import statement. I have it already. I don't need this data sets, the X and Y, I have them already. So from we instantiate, right? Okay, we can still plot, it's fine. Okay, so we instantiate, then we define the model, fit the model with the X and Y, and then we check for the feature importance. So when you do this, you can see that you have your top features. Now you have a very close tie. We have the int rate as the best, then followed by the log annual income, the revolutionary utility, installments, days with credit line, and all of that. So as the top 5. So let's just compare the two. So we have revolutional balance here. We also have revolutional balance here as number 5. So let me select my new X and Y for my algorithms. Yeah. So I'm going to define my X and Y. Here, I'm going to do final data. Because I'm selecting them one after the other, so I'm going to do this one after the other. Okay, so the first one I want to select is I'm going to use a revolution balance, which is within the top 5. So I'm going to use revol dots. I hope I'm correct with all of the spelling. Then the next one I'm going to use is days with credit line. Let me check if we have days with credit. Okay, we have it here. So I'm going to use that as well. Just copy it. So I'm going to do another one. I want to use the common 10. Then we have the next one. We have the installment revel is utility. Installment revel utility is there. So I'm going to use this too as well. Okay. Then we have the next one. We have in last 6 months. Okay, that's the 9th one. Okay, still okay, we can still use it. And then we have FICO. FICO is there as well. We have purple small business. Purple small business is not here, so I'm going to drop it. Let me just use this and this. DTI, let me see if DTI is there. It's here. We have credit policy. Credit policy is not here. I'll leave it. We have public.rec. Public.rec is not here as well. I can leave it. DTI. Okay, DTI is here. All right, let me just drop the ones that I have sent first. Okay, so we have Subafico purple small business is not here. Then we have the DTI. DTI is not here. DTI is not here. And then we have, okay, DTI is here. Then we have credit.policy. Credit policy is here, is not here. And then we have pub.rec. Pub.rec is not here. So there are some very close ones that are not included. 6, 5, 4. Okay. Let's do the DTI. Another thing I want to is so I have like 1, 2, 3. I have 7 features. I wanted to get 10, but I noticed that int.rate, which is the best feature here, is not here. Int rates. Int rate is not here. So I'm interested in that integer rate. What is it? The integer rate is the interest rate of the loan as a proportion, borrowers judged by to be more risky. So I think that would be a very good predictor. I can include it, even though it's not on the other feature selection algorithm. I think I can include. So when you're doing your feature selection, there's a lot of iteration going on there, that you can consider, because after I can decide to say, let me first of all build with these first 7, right? But I can decide not to. Okay, let's just go ahead with this first 7 and see what the answer would look like. Okay, let me define my Y. Let me see what the results would look like. Okay. I'm more interested in the other model because that one gave me a better accuracy. So I don't want to focus on chain test bit not defined. What happened? Okay. So here, we can see that our accuracy score dropped. So I think it was 77 before. Was it 77 or something? I've already cleaned it, but then it dropped. Let me try it for this one. This one is 70. This one was 78, but let's try it again. Let's see what since we have a new X. So let me reload my X. Come here. Let me run the random forest because I'm interested in the random forests. It's still fitting. It's taking a while to fit. Okay, it's done. I have 78 right now. Let's see. Okay, it's still the same thing. It's still 78. But then let's see it's dropped. Okay, we have 84% accuracy and 78 as the F score. I think it improved a bit. I'm not sure. So that's why if once you do your modeling, you have a lot of iterations. I'm not supposed to clean this one. I'm supposed to create another separate sheet for it so that you can be able to compare the differences between the two. So now we have 70. So I can decide to include some of those ones I feel that I left out, like this int rates, this log annual income that was not here, which is also a very strong predictor here, right? The int rate, the log annual income, the revolution utility is is here. So these two strong ones that I dropped, I can decide to include them. So let me include them. Log, let me see how it's written so that I don't get into error. Log.annual.income. Okay, so let's try this again. Let me decide to load it again. So I've loaded our X and Y. Let's check that. Now the decision tree, we have this. So here it was 73. Let's see if it's going to be better. Now it has improved to 74. But I think our previous model was, I think, better. But let's see the other one. So let's see this one. For our random forests. It's taking a while to print. Still train. Okay, it's fine. So we have our X tests. Okay, so here we have this. So here we had 78 as our weighted average and 84 as our accuracy score. So let's see what the new one would be. So you see that our accuracy has increased to 85. This has increased to 80, and this has increased to 80. So this one has actually improved the model a bit. So we have I recall the recall jumped. There was a whooping jump on our recall. Our F1 score is also very, very great, right? We have the accuracy average is 8.85, and then we have the weighted average as 0.85. Now this is 0.78. F1 score 0.85, and then we have the 0.80. So you see that it's better, it's a better result compared to the last one, which we did based on those. So you can keep adding some features. Then you can also look at your visualizations, those features that you think that might be good indicators as well. So that would give you an idea of what, how well your model is performing. So there's also something that you can do, which is like you adding weighted average, dealing with data imbalance. I didn't cover that, like you on the sampling, the majority class, and oversampling the minority class. So there's a way you can also do that just to have a balanced data. But sometimes when you do that, it might add noise to your data set, because like you are replicating the minority class that has like maybe 100 columns, and the majority class, maybe if the majority class have 500 columns, 500 rows, and the minority class have 100 rows. So you can decide to oversample the minority class by adding more samples to your data sets, replicating it. There's some algorithms you can use to do that. Replicate it such that it will have a balanced data between the majority and the minority class, and then build your model with that new data set. So you can do that as well. By that way you can also deal with imbalanced data set. But sometimes you have that it's add noise to your data set, like you're having replicated data generated, and then you're adding it to your model, so it might not be the best approach. Then there are some algorithms you can also use that helps you to automatically add class weights to your data. So I don't want to cover that here, because I want you to digest these ones first, and then we can look at that later. All right, so I believe you were able to understand this so far. I wanted to take one more example, but I don't know if you have questions. Do you have questions so that we can treat them? Do you have any question? Any questions? I'm waiting. Do we have any questions? Yes or no? You can just drop in the chat so that we can go ahead if there are no questions. All right. So if I'll take our silence as no questions. Okay, so let us look at one more data set, then I'll show you what you want to, I mean, what you like, what our projects would look like. Then next class we'll try to, walk through an example project and see how you can replicate that if you're going to do the machine learning capstone projects. Okay, so there is this data set on upcoming. Let me just get the data. Okay, there's this Kyphosis data sets. I'm trying to get the data description so that we'll be able to be on the same page regarding the data set. Okay, the one I saw here doesn't have a data description, but let me check for another one. Kyphosis data sets. It's actually a disease. Kyphosis is a disease that has it's a disease of the spine where there's an extra curve, excessive curve of the spine. So I want to check the data description of what each of those if each of those features mean so that you'll be able to understand what it means. Okay. Okay, it's I just got one. I don't know if this is the hair. This is how the disease looks like. Normally the spine should not be so curved. So you can see the way this spine is really, really curved. Okay, so we have kyphosis is an abnormal excessive convex curvature of the spine. And then we have the age in months, the number of the vertebrae involved, the number of the first top mode vertebrae operated on. Then the kyphosis is a factor with level absent, present, indicating if kyphosis, a type of deformation, was present after the operation or was not present. So this is a classification problem. And we want to build an ML to predict whether if you input the age of that particular disease and then the number of vertebrae involved and then the number of the first vertebrae that was operated on, right? And then it will give you an output whether the kyphosis is present or not in that particular spine. So this is like more of like a medical kind of problem. Yeah, so we're going to just look at that very quickly and see how to approach it. So by these examples, you're seeing there is a similar pattern in handling classification problems. You see that the same pattern goes for your regression as well, but the difference is just the data manipulation, how you have to manipulate your data, and then how you have to, do your feature selection, feature engineering. That would determine what, and then the type of the algorithm you're going to use on your data. Okay, so now given the data set, we have the data, you read the data, and then you do some EDA, like you can check if Kyphosis, do a pair plot, Kyphosis. On the age, you can see the relationship between the age and whether kyphosis is present or not based on the person's age and the number and the stats where the kyphosis is starting from. So to build a machine learning model, we didn't do so much visualization on this, right? But then to go into the model development, you see that you do your train test splits, select your X, that's your feature values, and then your targets, which is a kyphosis, and then you have the X train, X test, Y train, X, Y test as your train test splits. Okay, so we can train a single decision tree classifier. And when you do that, you do your import decision tree classifier, just like we did for the previous example. We have the fitting, we fit it with the training sets. And by doing this, you've built your model, then you make predictions on your data sets. And here, after doing that, you can now do your evaluation. Upon evaluation, you can see that your kyphosis is absent. You have a precision of 89. Kyphosis present. I mean, recall you have 88 as your total. I mean, your average. But then you can see under absent, you have a 90, 95, 90, 93, and then your present, you have 60, 75, 67. By the way, the last one that we looked at, there is a lot of overfitting going on, because if you compare the recall score with the category of 0 and then the one of 1, you can see that the recall, this one is 99%. That is, it's telling you that that for the one that was not present, that the one with 0 had 99% recall, and this one was 3%. So this is showing you that there is a there's a problem. There's a problem with these particular results. This, I mean, this is definitely overfitting, right? Is overfitting on the majority class. So we have to also deal with that using we have to do some data imbalance, having to deal with overfitting issues. All right, so I just thought to mention that compared to this one, this is still slightly okay. You have now, before that, let's even check the balance. I mean the data distribution between. That means I have to load this. I didn't want to load that because of our time before. So let me just load it. Okay, this is also slightly imbalanced. We have 64 to 17. That's about a ratio of this is also imbalanced. Yes, this is imbalanced, but it's not as much as the other one. But let's just look at the results as well. You see that this gave a better result compared to the last data set. So you have your recall, the precision, and the F1 score, and the average for your confusion metrics. This is a very good. This is very good because you have little. I mean, little or no. This is a perfect model. Is when you have this place 0 and 0, and this one you have your true positive and true negative. That is, it's telling you that it was perfectly predicted. The accuracy is very great. All right, so here it's showing you that the model is doing a bit well with this kind of results, but then the incorrect predictions are these 2 and 1. It's a very relatively small data set though, so we can't judge on that. But let's go further to check our random forest classifier as well. X-train is not defined, so I need to load the X-train data sets. I need to load that as well, so I'm going to load that now. Sorry for the break. Sorry for the break. So when you load your train test splits, your let's load our training tests. Train and test split. So I'm going to come back here to, we're doing the random forest. So I'm going to come back here to load that. Okay. Then we'll do our predictions here. Okay, I need to define confusion metrics. I need to load it. So let me load the confusion metrics. Then confusion metrics not defined. So let me load the confusion metrics from here. I'm just going to get this so that I don't okay, so we have this. Let me load this again. So here you can see that we have a better accuracy score, but then you see our for the present category, the precision recall and F1 score dropped drastically. And we have the confusion metrics as the same. So if I was to choose between the 2 models, I'm going to, even though this is a better accuracy score, I'm going to use this model because this model is showing me that we have, let me load this from the beginning so that you can see the difference. Let me load the decision tree classifier. Okay. I think it's because I've been loading them at intervals. So I'm going to, let me just load it from the beginning so that we can see what is actually going on perfectly. Okay. There's a problem somewhere because this was way higher than this. We had something like around 70, 80 something, right? We had something like 80 something, and now we are seeing a drop. Okay, so you need to take note that when you're doing your modeling, right? So it's good to try to create separate notebooks so that you don't mix up the code, because Python is a top-down programming language, such that when you load something on top, it affects the next cell. So you have to be very careful. Now it's like there's a misunderstanding between what I've done before and now. I see that I'm getting a very different result. So usually you can create separate notebooks for different algorithms. It's not going to take you it's almost like duplicating it, and so that you know that this one is for this model, this one is for another model, and then you can always focus on this. But from what I showed you earlier, this model was performing better because we had a better precision and recall for the two categories. All right, so that's just another example on how to use your decision tree and random forests. Okay, so for other algorithms, if you go to sklearn, you see many other algorithms on classification. You can try your hands on some of them, try to use them, and also try to read on, okay, which algorithm is best for different. There's some algorithms that are good for some particular use case, and some are better for other use cases. So you have to just also know which one to use at every point in time. All right, so I don't know, do we have any questions from now? So when you get to sklearn, you see classification, regression, clustering. But I wanted us to do clustering before, but we won't be able to touch on clustering. So we just focused on classification and regression here in the bootcamp. Okay, so we touched on classification, regression, we touched on model selection, right? When we did our training test splits, and model selection houses the metrics that we've been using, then the training test splits as well. The preprocessing covers the one-hot encoding, label encoding. This is for dimensionality reduction. I didn't touch on that here. It's also good for feature selection, PCA, principal component analysis, feature selection, non-negative matrix factorization. They're all dimensionality reduction techniques to help you choose best features. So I think we did good justice on we touched on feature selection. So we touched on almost all of sklearn's packages for the bootcamp, at least the basic one. So you can always build on it. The most important thing is also be comfortable on learning how to use them and how to apply them. Then you can always expand from there. Do we have any questions? So when you go to classification, right, you see different, you see different algorithms under the linear models. We used the logistic regression. So logistic regression, you see the linear regression here as well. Under the linear model, you have the lasso, the ridge, and some other models under linear models. So let's just go back to class. Oh, you're not seeing what I'm saying. I thought that you were seeing what I'm saying. Sorry about that. Let me just share the page I was showing you. I didn't know that I was not showing you the right page. So I was showing this page initially. This was what I was showing. I was showing this. That was what I was showing initially. All right. Okay, so do we have any questions? Any questions? All right, if there are no questions, we would, before we go, because for the sake of people that want to start up their project, so the project is already loaded up on the LMS. When you go to the LMS, you see the project summary on the today. And here you're expected to do a machine learning task, build and evaluate a machine learning model on a given data set. So you can get a data set, like you see that we've done several examples. We used the loan, we did we did Titanic dataset predictions. We did some regression problems, the social media advertisement classification. We worked on the lending club data. We worked on the Kyphosis data sets. We worked on different data sets. So you can also look at some data sets, could be a very simple data set, and try to replicate it, run through it. You can follow all of the examples we've been using in class, follow it, and then you come up with your model. You can use any of the machine learning models that was explained. So you have to identify the problem you're trying to solve. Is it a classification problem or regression problem? And then you use the right algorithms for that problem. Okay, so we'll be showing a walkthrough of projects next class. So don't miss next class. We'll be showing you a walkthrough and, if possible, how to deploy the projects to production next class as well. Okay, so if there are no questions, we're going to call it a wrap, and enjoy the rest of your evening, everybody.